Mr. B, this is lesson 3-6. All things being equal, we're now going to work on inequalities and multiplication. There is some vocabulary for this. You should make sure you know it. You know them. Inequality, boundary point, interval, and endpoint. You should know what those means. Inequality is shown to you right away. You'll see that right here at the start, where we've got it in bold, and it's a mathematical sentence with one of the verbs, less than or is less than, greater than or is greater than, the is less than or equal to, or is greater than or equal to. Those are the sentences we want to look at. There's some discussion in here. You really should read this, as you should be reading everything. That's part of your work, is to read through these lessons. But take a look at it and see what it tells you there about how this might be done. In this first one, the 3 is the boundary point, but 3 is not the solution. And they talk about it down here when it talks about boundary point. So again, make sure you read through that and understand it. Something that's not really highlighted, but I believe you're going to need to know this, is this idea of set builder notation. And set builder notation is written as this right here, where it's in brackets. It's x such that, or the set of x such that x is greater than or equal to 3. Now this is just one instance of set builder notation. You may find others that where you have to write a different set. It might be a listing of things, it might be an inequality, but it's written in brackets with the term that's being defined, the variable, and then the colon, and then the variable and what its conditions are. That's set builder notation. Be aware of that as you're going through this. When we look through this type of work, graphs of inequalities on a number line, you can see on the right side of the page where it says there's exactly one solution. Well, that's an equals thing. When x equals 3, it's that dot, closed dot, filled in right at 3 on the number line. When we have an inequality, we have an infinite number of solutions, because anything that makes it true is a possibility. So in the first case, where we see that one, that x is greater than 3, we see that at 3 there's an open circle. We have to mark the boundary point. Whether it's included in the solution or not, you need to indicate it. We indicate with an open circle that it is not included in the solution, but it is our boundary point, and everything to the right of 3 is a possible solution, which means you can become infinitely close to 3 as long as you're not exactly at 3, and that still is a solution for x is greater than 3. The next one down shows us x is greater than or equal to 3. You'll notice that that circle has now been filled in. It's a dot. That's because 3 is part of the solution. So it's included. By filling that in, we say 3 and everything greater than 3 is a possible solution to this inequality. Okay, next page, we're talking about things that might lead to double inequalities. Double inequality is an interval. I think you should be used to seeing this when we describe the interval that is the window on your calculator. So if we had a calculator window, let's say this one, well, that's not a graph, so I can't use that one. It might have been -10 to 10, and we would write that as a double inequality. This one, in which we talk about Mount McKinley, which has a double inequality, and it ranges from this Death Valley, which is below sea level. We're going to go there for our biome trip. To Mount McKinley, which is not too far from us, up in Alaska. So that's at 6,194 feet, or meters, excuse me. And so we've got our range of elevations in the United States goes from a negative 86 meters, which is less than or equal to x, and x is less than or equal to 6,194. This is an interval. We might say this, that x is greater than or equal to a negative 86 and less than or equal to 6,194. You'll notice in an interval that the inequality symbols always will point the same direction, because we'll begin at an endpoint, we'll go to the other endpoint. They won't point away from each other. They're always going to be in the same direction for this kind of a double inequality. So that would be an interval. We'll go through the activity once I get finished with the discussion of the lesson. I'm going to do this both by hand and with the CAS. There's some properties, you really need to know them. The first is the multiplication property of inequality. Like as with the multiplication property of equality, what we do to one side of the equation, we have to do to both sides of the equation. For an inequality, what you do to one side of an inequality, you have to do to both sides of the inequality. The difference here in multiplication is that if x is less than y and a is a positive number, then multiplying x and y by a has the inequality having the same direction. In other words, ax is less than ay. So here's a case of where things might be the same. So if we have these in order and we multiply any of these by 2, so we look up here, we say negative 20 times 2 is negative 40, and we'll make an inequality real quick here. So we have negative 20 is less than 10. Now if we multiply both of those by 2 times a negative 20, which is still less than 2 times 10, we can see that negative 40 is less than 20. And that remains true. The more negative something is, the less it is. The more negative of the negative is gets less and less. A negative million is less than negative 1. The positive side increases. So as we move to the left, we're going to lesser values. As we move to the right on a number line, we're going to greater values. So left on the number line, lesser values. Right on the number line, greater values. Now the other part of this, part 2 for the multiplication property of inequality, is if a value is negative. So let's take a look at what might happen here if we have a negative value. And so the example is multiplying by a negative 2. So if we say that, let's see, 20, let's start with, we'll go with 12. 12 is less than 20, which is true, and we're going to multiply that by a negative 2. So negative 2 times 12, which is less than a negative 2 times 20. So that seems to be true. And let's see what happens. So negative 2 times 12 is a negative 24. Negative 24 is less than negative 40. Hey, wait a second. We just got done talking about this, that a negative million is less than a negative 1. So the more negative something is, the less value it has. And now we're showing that a negative 24 is less than a negative 40? That can't be right, because that doesn't deal with what we saw before. So what we see here when we do this is where 12 is less than 20, that's absolutely true. But once we multiply it by a negative number, then we have to go in and change the inequality from a less than to a greater than. We have to flip it because we multiplied on both sides of the inequality by a negative number. So we have to change the sense of the inequality to reflect the fact that now that we're talking about negative terms, the relationship is changed. If it's farther away from 0 on the left side of the number line, it's a lesser number. Okay, so what we've got is, yes, we can multiply both sides of the inequality by the same number. We have to watch out for the inequality sign and make sure we recognize when we need to flip it, which is when the number we're multiplying by is negative. At that point, we need to flip or change the sense of the inequality. To solve an inequality is just like what we did with inequality, except one, we're dealing with an inequality and we have to pay attention to the sense of the inequality. And two, when we check it, we have two things to check. One, you have to check and make sure that the boundary point is correct. And the second thing you have to do is check and make sure that the inequality is pointing in the right direction. So here we have our example 1. We're going to solve and check it. It's just simply a multiply by the inverse. We get that it got flipped at the point where you multiplied by a negative value on both sides of the inequality. We flipped the inequality, changed its sense, and we got a boundary point which tells us that x is less than or equal to a negative 18. We check for the negative 18. We check for the boundary point. Does it work? Yes. Great. Now we find a number where x is less than a negative 18 and put it into the inequality. Does it work? If it does, then yeah, we got the sense of the inequality right. If it doesn't, we may have the sense wrong. You need to check both of them. It's not enough to just check one because you have two things you have to verify. Come back to the guided example in a few minutes after we do the other one and a couple other extra examples. As usual, your work is covering the ideas and applying the math. Make sure you read this lesson carefully and work through it carefully. Pay attention to your signs and when you have to change the sense of the inequality. It's really easy to miss it. One more thing to keep track of. Looking forward to seeing you on the mastery quiz. I wish you the best of luck with that. And we will continue on. I'll continue on with the guided examples. Okay, this is the continuation of 3-6, the first activity, where we're being asked to use the CAS to solve some inequalities and see what happens. So the first thing you probably want to know is, where is the inequality symbol in this calculator? How on earth am I supposed to find it? And I'll show you real quick. If you look at the equals button, it's going to be in red right now. Up above it in blue, there's some other symbols. There's a not equals, there's a greater than or equal to. And to get to that, we hit the control button. Control changes the function of the key. So I'm going to clear out this. hit Control and the button, and now I see I've got a set of values that I could use. This straight up and down symbol is not absolute value. It's used to indicate a bracket that we'll come to later in terms of functioning. So let's see, our first one, we needed a less than symbol. So I'll go ahead and just pick that. Guess it doesn't help me because I didn't put in any numbers, did I? Okay, we'll get rid of that. And it's 2 times x. 2, remember we got to put in the multiplication, times x. Now I go to Control and less than, and it's less than 8. And so we got that in, I hit enter, and it's telling me that 2 times x is less than 8. To solve an inequality, and remember it's just very similar to what we do when we solve equalities, we just have to watch out for the inequality sign. And in this case, if we're going to solve this, we're going to multiply by the inverse of 2, which is 1/2, so it's like dividing 2 by 2. So we're going to divide both sides of the equation by 2. Or we could multiply both sides of the equation by 1/2. Let's try the 1/2 real quick. So we're going to do the answer times 0.5 and enter. And we can see that 2 times x becomes x, 8 became 4. Both of them were divided by by 2, or multiplied by 1/2. So we can easily see how we could do that. Let me go back real quick for those of you who I've confused. And we're going to go to here. We're going to say divide by 2 and enter, and we get the same thing. So 2 times x, which is less than 8, divided by 2 gives me x is less than 4. So that's our first one. That's for number 1. Let's take a look at number 2, and this is 2 times x is less than, and we need to have a sign in here. So where do we get our negative sign? This is plus and minus. This is an operation symbol. Right down here is our negative symbol. So negative 8 and enter. We want to divide that by 2. This is really the same procedure as above. Divided by 2, enter, and we get that x is less than a negative 4. So everything stayed the same because we were only working with positive numbers. And we'll go on to this next one. Number 3 was 2x is less than or equal to 8. Pretty easy. 2 times x, that is less than or equal to 8. Enter. We divide this by 2. Divided by 2. Enter. And we get that x is less than or equal to 4. This is how we have to represent the answer. It's not a single answer. It's a range of values that could make this true for any of these, where it's possible that if x is 5, it's true. If x is 2 million, it's true. If x is 4, it's true. So there are many ways to make this a true statement, not just one. Okay, number 4 is a negative 2 times x is less than 8. So negative 2 times x is less than 8. Now in this case we have a negative value, and so when we divide both sides, we're going to divide both sides by a negative 2, because a negative divided by a negative is a positive, and we want a positive value for x. We want that to be whatever x is, not the opposite of x. And because of that, we would expect that the inequality is going to flip. So let's see what happens. So we're going to divide by -2, enter it, and indeed we see that when we did this division, our inequality flipped as we did it to both sides of the inequality. And now we have that x is greater than a -4. So let's try number 5. That was a -2 times x, which was less than or equal to a -8. Now what's going to happen on this one? Let's try it. We're going to divide by 2. Excuse me, we're going to divide by a -2. A -2, because a negative divided by a negative is a positive, and I want to get the value of x, not the opposite of x. And I get, again, it flipped it. The x now is greater than or equal to 4. -8 divided by -2 is +4. So we've got number 5. Let's take a look at number 6. That's not 3. 2 times x, which is greater than 8. We enter that. What are we going to do? We're going to divide both sides by 2. Divided by 2. I get that x is greater than 4. And finally, let's look at number 7. -2 times x is greater than or equal to, is greater than or equal to, 8. We divide by a -2, and our answer then is that x is less than or equal to a -4. We flipped the inequality each time. Now let's take a look at 8 and 9. I'm going to move away from the calculator here and go to the sketch pad, and we're going to do this by hand. Check your results with your CAS when you're done. If you don't have a CAS calculator, remember that your job is to do this by hand and check your results. So you should go through it in that way. Okay, this is the rest of the first activity for 3-6. This is number 8, where it asks us to solve it and then check it with the CAS. So 4m is greater than a -20, and we can take a look at that one. And our first step is to clear the coefficient from the m, and so we want to take the inverse of 4, which is 1/4, times 4m, which is greater than a -20, and 4/4 forgot this, times 1/4, wow. And this is all over 4. So 4/4 is just 1, so m is greater than a negative. 4 goes into 20 5 times. So m is greater than a -5. That's it for the first one. Check it on your CAS. Make sure you got it right. So go ahead and try the next one, and then I'll present that to you. You might want to pause this while you work on number 9. Okay, here's number 9, and it's a -10w is less than or equal to 62. Our first step is to multiply by the inverse, so 1 over a -10 times a -10w is less, no, I flipped this because I'm multiplying by a negative, right? So I have to flip that right now, right here. Okay, so 1 over a -10 times a -10w is greater than or equal to 62 times a negative 1/10. Negative times a negative is a positive. 10 over 10 is just 1, so I've got W is greater than or equal to, and 10 goes into 62. I just move the decimal point over one place, and it's a negative, so it's now a negative 6.2. So check this on your CAS, see what you got. Now the last part of this, question 10, asks you what's the difference between the categories up there. If you could group them into two categories, what would it be? And we keep talking about what's the difference between working with inequalities versus working with equalities, and that is you have to pay attention to the sense of the inequality. And the difference, the two categories you're going to see, are the questions where you have to flip the inequality or change the sense of the inequality, and the questions where you don't. So where the coefficient of the variable is negative, and you have to multiply both sides of the equation by a negative sign, you have to change the sense of the inequality. When the coefficient is positive, you multiply both sides of the inequality by a positive number. You do not have to change the sense at that point. Alright, so we're continuing on with 3-6. This is the guided example, example 2, and it asks that you solve 20 is greater than or equal to 4 times x. Graph the solution and check your answer. So let's just walk through what they're looking for here. We write the inequality. You multiply each side by the reciprocal of the coefficient of the variable, which is, the coefficient of the variable is 4, its reciprocal is 1/4. So we multiply both sides by 1/4. 4 goes into 20 5 times, and so 5 is what related to x? And 5 is, since we leave the inequality alone, is greater than or equal to x, which could also be rewritten as x is less than or equal to 5. We could go ahead and just reposition them in that way. So that's the part A. It asks you to graph the solution on a number line. And to graph the solution on a number line, you'll need a line, of course. And we'll go ahead and just get a line here. Put some arrows on the end. This line's name is x. It's the x number line. It's less than or equal to 5. 0 could be anywhere on here. Doesn't have to be in the middle. I think I'm going to put it kind of here. So I've got -1, -2, and 1, 2, 3, 4, 5, 6, 7. Okay, so I've got a number line. It's the x number line. I have that x is less than or equal to 5. So 5 is included in the solution set, which means I put a dot there. I fill that in. That's part of the solution. The remainder of this is that it's less than that, so the numbers less than it are here to the left. And we've got a couple of ways we could represent this. One way, if I'm using just one color like this, is to put a little line above the dot. Go ahead and put your solution line up there and just draw it like that. So that could work pretty well. Another way to do this is to go in to the pencil case, grab a colored pencil of some type, and now I'm going to come back in, and instead of being in the same color as my line, I've got a very different color, and I would indicate that this is my solution set, and I can draw that right on it. If I do that with the same color, you really have to kind of, fill it in to indicate that it's more than just the line underneath. So either way would work, whether you put the line, put the ending bar up and then a line across, or just mark it right in on the number line is fine with me. And so those are our solutions to this. The next part of this is to check our work, right? So let's take a look at how we might check our work for this one. We'll get this out of here. Go ahead and get another screen. And we had that our value was that x was less than or equal to 5. So the first thing we do is we verify our boundary point. Our boundary point was 5. The original equation was 20. Is greater than or equal to 4x. So now we want to see whether it's true that 20 is equal to 4x, so is greater than or equal to 4 times 5, and 20 is indeed equal to 5, and it's greater than or equal to it also. So my boundary checks. So that's my first check. My second check is to go in and look and see, is the inequality pointing the right direction? In other words, if I pick a number, I said that x has to be less than or equal to 5. If I pick a number that is less than or equal to 5, will it be true that 20 is still true? So let's try a number, and we'll say that x equals 0, because 0 is easy. And if x is 0, then that means that 20 should be greater than or equal to 4 times 0. And indeed, 20 is greater than or equal to 0. It's a greater than or. It doesn't have to be equal. It just simply has to satisfy one or the other parts of this. So my two checks have worked out. I've verified it, I have graphed it, and I've shown that indeed it is equal. The last part of this lesson is in the tan box, the multiplication property of inequality. It's in words. Read it. Make sure it kind of sits into your head. I'm going to go through a couple of other examples here. Just if you need some more help, take a look at it, or come back to it if you find you might be a little confused. So I'll see you at those examples. Okay, I'm carrying on with some additional examples for 3-6. If you need some help with this, this would be a good time to do it. First off, I just want to go through a basic inequality. Negative 5 times x, so negative 5x. We don't have to put the multiplication symbol when we're writing it. And that's less than or equal to 35. We want to solve and check this. So first thing is what's the coefficient of x? It's negative 5. What is the reciprocal of that? Well, that's a negative 1/5 times a negative 5x is less than, I keep doing this, is I have to flip it, right? Because that's a negative right there. So I flip right here, is greater than or equal to 35 times a negative 1/5. Negative times a negative is a positive. 5 over 5 is 1. I'm left with x is greater than or equal to a negative. 5 goes into 35 7 times. So we get that x is greater than or equal to a negative 7. I want to check my boundary conditions. So the first thing I want to know is if x equals 7, is it true that 5 times 7 equals 35? Or if x equals a negative 7. So negative 5 times a negative 7 equals 35. And negative 5 times a negative 7 is negative times a negative is a positive, so 35 equals 35. I have verified the boundary point for this problem. Now I want to check and verify that the inequality works. If some number is greater than or equal to -7, will it work? Well, what's greater than or equal to 7? How about 1? There's nothing that says you have to use hard numbers. You can use something that's simple. If it works, it works. If it doesn't, it must mean it goes the other direction. X equals 1, so if x equals 1, then a -5 times 1 is less than or equal to 35. -5 times 1 is a -5, and -5 is indeed less than or equal to 35. It checks. So let's take a look at another one where we're going to solve for a variable, and we're going to graph the solutions. And so here we've got 13a is greater than a -65. So coefficient of a is 13, so 1 over 13 times 13a is greater than a -65. I don't have to flip that because that's positive, but I have to do the same things to both sides of the inequality. And so a -65 divided by 13, anybody know what that is? I know it's going to be negative, because a negative over a positive is a negative, and it's 5. Okay, so a is greater than 5. We want to check it real quick. What's our boundary point? Our boundary point is 5. So if a equals 5, does it make it true that it's going to equal a -65? So 13 times 5, does it equal a -65? And it doesn't, because that's a positive. What did I do wrong? Oh, right there, I dropped my negative sign. Dropped my negative sign. Okay, so I need a negative there and a negative there, and a -5 times 13 is a -65. So I verified my boundary point. Now, I'm not saying that this is a solution for the original one, because it wouldn't be. It has to be greater than that, not equal to it. But I'm verifying where I'm going to draw my, put my boundary point on a number line. And I'll show you the number line in just a second. Let's just verify direction. So a is greater than a -5, so if a equals, I'll use 1 again, which is greater than a -5. If a is equal to 1, then 13 times 1 is greater than a -65, and indeed 13 is greater than -65. It checks. That checks. I caught my dropped negative right there, so that's a good thing. Now let's go ahead and we're going to plot this. I'll fade this out a little bit, and we're going to make our number line. Put some arrows on the end. And we've got it. It's a is greater than a -5, so I'm probably going to put my 0 around here. 1, 2, 3, 4, 5, 6. 2, 3, 4. 1, 2, 3, 4. -1, -2, -3. So -5. Now -5 is our boundary point, but is -5 included in the solution set? And so if I look at that, I see that a is greater than a -5, but not equal to it. So what that means when I'm graphing this is what I'm going to put at my boundary point is a circle right here to indicate that I'm beginning at -5. That's a endpoint, but -5 is not part of the solution. And since it was any value greater than that, I'm going to indicate this way that here is my solution set. Now again, I also could have come in with a different colored pencil, written it here, put it in like that, or I could have used my original color and just kind of marked it up in this way. Okay, so this is the solution to our problem of 13a is greater than a -65. Okay, let's try another one real quick. And this is -7/4 f is less than or equal to 9 plus 5. That's kind of different. Alright, so first off, I've got to combine like terms, right? I've got 3 terms here, but I've got a common factors there. Those are just 9 and 5. I could add those together. So I want to do that first thing. So -7/4 times f is less than or equal to 9 plus 5 is 14. So that's good. Now I find the reciprocal of -7/4, and I need a negative because a negative times a negative is a positive. And I want to multiply it by its reciprocal, which is the value that will make a 1. And that would be 4/7 times a -7/4 f. I used a negative here, so I need to flip the inequality. Is greater than or equal to 14 times a -4/7. Negative times a negative is a positive. That's a 1. That's a 1. 1 times -1 times a -1 is 1. 1 times f is just f. And f is greater than or equal to, let's see, 7 goes into 14 2 times. 2 times a -4 is a -8. And I see that f is greater than or equal to a -8. So let's go ahead and we'll check this. And if f is greater than or equal to a -8, I want to know if f is here we go. Okay, if f equals -8, does the original equation work out? So a -7/4 times a -8, does that equal 14? Let me get rid of that underlying layer. There we go. And we get 4 goes into a -8, a -2 times. A -2 times a -7 is 14. And so indeed I get that 14 equals 14. And my boundary point checks out. Now I want to verify the inequality, and what did I find in this was that f is greater than or equal to a -8. So I need something greater than a -8. How about 2? Just to make it interesting? No? How about 4? Okay, if f equals 4, if f equals 4, then a -7/4 times 4 should be greater than or equal to, is that correct? Oh, less than or equal to. Good to check these things. Less than or equal to 14. And a negative times a positive is going to be a negative, and 4 over 4 is just 1, so I'm going to get 1 times a negative 7, so I get a negative 7, which indeed is less than or equal to 14. So that checks. My first one checks. I could graph this on a number line. What I would include would be a dot, not an open circle, because it is, the boundary is included in the answer. And we will go from there. So that's it for your extra examples, covering the reading, applying the math. Head on to the Mastery quiz.